Discover the precision, power, and expertise behind heavy truck and crane installations, mastering the transport of oversized cargo safely. The Demag AC 500-8 stands as the largest land-based crane operating in southeastern Mexico, a symbol of engineering strength and industrial progress. With an impressive maximum lifting capacity of 500 metric tons and a reach of up to 145 meters when equipped with its specialized luffing jib, this 8-axle titan is engineered to meet the region's most demanding onshore lifting challenges. Its 56-meter telescopic boom, compact frame, and exceptional maneuverability allow it to work efficiently in refineries, offshore support bases, and large-scale construction sites where precision and reliability are essential. All-in Service, a company known for innovation and technological commitment throughout its history, introduced the AC 500-8 as a milestone for Mexico's oil and energy industry. As the only provider in southeastern Mexico capable of offering such a high-capacity crane, the company demonstrates an unwavering dedication to quality, safety, and performance. The AC 500-8 is equipped with advanced safety systems, including an electronic immobilization unit that prevents uncontrolled chassis movement, semi-automatic counterweights totaling up to 180 tons, and a dedicated camera-based monitoring system for cable supervision. Its dynamic design enables operation across a wide range of weather and ground conditions, ensuring continuous performance even in challenging environments. Supported by All-in Service's strategic locations in Ciudad del Carmen, Ceiba Playa, Dos Bocas, Veracruz, Tampico, Nuevo Laredo, and Laredo, Texas, the crane delivers reliable service nationwide and beyond. The Demag AC 500-8 is not just a machine. It is a statement of technological leadership, national commitment, and the drive to elevate every project it serves. The replacement of the Rickmansworth Met Rail Bridge in 2016 was a highly coordinated infrastructure operation combining heavy lift engineering, track removal, civil works, and precision installation. The project was executed over a tightly controlled possession window designed to minimize disruption to both road traffic on the A412 and rail services along the Metropolitan line. Throughout the operation, each phase was carefully sequenced in order to remove the aging structure, prepare the site, and position the newly fabricated bridge, which had been assembled and tested off-site before the main lifting event. To begin with, preparations started well in advance of the possession period. Engineers first carried out detailed surveys of the existing bridge, identifying structural interfaces, bearing positions, and alignment constraints. Because the bridge spanned a key arterial road, the A412, traffic management had to be developed in coordination with the local authority. This included planned closures, diversion routes, safety barriers, and communication with the public. Meanwhile, the new steel bridge was fabricated in a staging area adjacent to the corridor. This location allowed crews to build the structure to full dimension, apply protective coatings, and install secondary components such as walkways and cable trays. As the possession date approached, the new bridge sat fully assembled, waiting to be moved across the A412 at the critical moment. During the possession weekend, the first visible step was the blocking and isolation of the railway. Signaling and power systems were safely shut down, and crews erected exclusion zones to secure the worksite. Track teams then moved in to remove the ballast and rail panels that ran across the old bridge. The last piece of track removed marked the beginning of structural removal. This step was essential because the lifting cranes could not carry any unnecessary weight or attachments that might shift during the operation. Once the track was cleared, the attention shifted to the removal of bridge furniture, handrails, drainage components, conduits, and any remaining walkways. After that, teams began cutting structural connections between the bridge deck and the abutments. These cuts were executed using diamond saws and oxy-fuel torches, following strict sequence diagrams to prevent unwanted deformation. Temporary support frames were then positioned to stabilize the structure up to the moment of the lift. With the preparatory works complete, the first tentative lift was initiated. This moment was a critical test used to verify that the bridge had been fully released from the abutments and that the cranes were performing within their predicted load curves. Slowly, the old Rickmansworth bridge began to rise, suspended from carefully positioned slings anchored to the main lifting points. Engineers continuously checked for unexpected movement or rotation. Once the structure cleared the abutments, the cranes coordinated a lateral movement, swinging the bridge away from the A412 corridor and onto a designated laydown area. This delicate maneuver required synchronized crane operation, with lift supervisors providing constant radio communication to regulate speed, height, and slewing angles. As soon as the old bridge was removed, ground crews entered the now vacated span. Civil engineers inspected the abutments, ensuring they met tolerances for bearing installation. Structural bearing seats were cleaned, shimmed, and adjusted to match the design elevations. Any surface irregularities were corrected through grinding or concrete repair. The installation of new bridge bearings was a vital step because these components control the transfer of loads and allow for thermal expansion. With the abutments prepared, attention now turned toward positioning the replacement structure. The new bridge, which had been staged nearby, was the centerpiece of the operation. The new bridge waiting to be moved across the A412 represented months of fabrication and quality assurance. Crews attached lifting beams, slings, and softeners to protect the steel surfaces. Once all lifting points had been double-checked, the cranes began raising the structure. This and other lift phase required the highest level of coordination, as the new bridge had to be placed with millimeter precision to ensure perfect alignment with the existing track geometry. As the cranes elevated the structure, spotters monitored clearance above the A412 and around the work zone. Slowly, the bridge hovered over the road before being carefully slewed into final position. Engineers verified the centerline alignment relative to the track corridor using total stations and laser measurements. The final lowering sequence was executed in small increments, with crews observing how the bearings engaged the bridge. When the structure finally settled onto the abutments, it marked one of the most significant milestones of the entire project. However, installation did not end with the bridge being placed. Once the structure was secure, temporary restraints were installed to prevent movement while crews began the next stage, track replacement. Ballast installation crews delivered fresh stone using road rail vehicles. The ballast was distributed across the deck, compacted, and shaped to receive new sleepers. Track panels were then lifted into position, aligned, and clipped into place. Precision was essential because the Metropolitan line requires consistent track geometry to ensure smooth and safe operation of passenger services. With the new track laid, tamping operations began. Automated tamping machines were brought in to compact the ballast beneath the sleepers and correct the vertical and horizontal alignment. This stage also ensured proper rail level continuity between the newly installed bridge section and the existing track approaches. After tamping, crews performed stress adjustments, welding, and grinding to ensure that the rail joints met operational standards. Electrical systems, including bonding cables, signal equipment, and drainage components, were reinstated. One of the final engineering steps involved a final grouting operation. Grout was injected beneath bearing plates and at designated anchor points to secure the bridge in its designed position and distribute loads evenly. The grouting material also served to protect structural steel interfaces from moisture penetration. Once the grout cured, engineers performed a complete inspection, verifying that all parts met structural and safety requirements. As the civil and track works neared completion, crews focused on clearing the site, dismantling temporary supports, and reinstating safety fencing. Ballast shoulders were trimmed, walkways were reinstalled, and drainage channels were tested to ensure that the new structure would perform reliably under all weather conditions. Road crews prepared the A412 for reopening by removing detours, barriers, and signage. To conclude the project, a final inspection was carried out involving engineers from the rail operator, the construction firm, and safety authorities. They reviewed bearing alignment, structural integrity, track quality, electrical reinstatement, and compliance with design specifications. Once all checks were satisfied, the route was cleared for reopening. Ultimately, the completed structure stood as a brand new bridge for Rickmansworth, representing a successful collaboration between civil engineers, crane operators, railway specialists, and safety teams. The replacement not only improved operational reliability, but also contributed to long-term infrastructure resilience along the Metropolitan line. The CAT 6060FS is a flagship front shovel mining excavator engineered for maximum durability, safety, and productivity in the toughest global mining environments. Introduced by Meyer from Caterpillar Global Mining in Dortmund, the machine reflects Caterpillar's integrated operating model and advanced design philosophy. Its one-piece casting, optimized load path, and reinforced boom and stick ensure exceptional structural strength under severe digging conditions. The bucket cylinders are positioned for reliable lifting forces, while the machine's geometry prevents improper top-end positions that could affect service access or performance. Powered by two Caterpillar diesel engines delivering a combined output of approximately 2,000 kW, The 6060 FS meets modern compliance standards and maintains full power even in demanding operations. Both engines are protected by dedicated covers to enhance safety during maintenance. Critical systems such as high-pressure filters, cooling modules, and dedicated pumps are centrally located for easy serviceability. Operator safety and control are central to the design. The machine's service arm, inspection covers, and protected walkways provide safe access to all major components. Inside the cab, the control tower operating system, responsive joysticks, and advanced electronic monitoring give operators precise control over swing, travel, and bucket functions. Rugged, reliable, and highly accessible, the CAT 606 OFS stands as one of the most capable mining shovels in its class. The mobile crane operation in the town of Regen showcases the impressive capabilities of one of the company's largest all-terrain cranes, the LTM 1450-8.1. During the past week, this powerful 8-axle machine was assembled on site to carry out a demanding lifting task. The precise placement of a 60-meter-long, 13-ton concrete sewer pipe into the Schwarzer Regen. Because of the pipe's exceptional length and the confined working area beside a heavily trafficked road, the project required maximum accuracy, careful planning, and highly skilled crane operation. The LTM 1450-8.1, known for its high lifting capacity and long telescopic boom, offered the ideal combination of strength and maneuverability needed for such a complex assignment. Once fully rigged, the crane executed the lift with controlled step-by-step movements, ensuring the pipe remained stable while being lowered into its final position. Throughout the entire process, the expertise of the crew was evident. Their coordination, communication, and attention to detail illustrate the professionalism necessary for working in restricted spaces where even minor deviations can cause major difficulties. The footage highlights not only the technical performance of the LTM 1450-8.1, but also the logistical challenges of modern infrastructure work. This operation demonstrates how advanced crane technology, combined with an experienced team, enables the safe and efficient handling of oversized loads, even under demanding site conditions. Installing a tower crane for wind turbine maintenance begins with preparing a stable foundation. The crane pad is surveyed, compacted, and fitted with steel base plates to ensure even load distribution. Next, the mobile crane positions the tower crane's base section, which is anchored using high-strength bolts. Additional mast sections are then lifted and stacked vertically, each one aligned and secured with precision pins. As the tower rises, internal ladders, platforms, and electrical systems are connected to support future access. The slewing unit and operator cabin are installed once the mast reaches the required height. These components are lifted in controlled movements and carefully guided into position to avoid any torsion on the tower. Afterward, the jib and counterjib are assembled on the ground, rigged, and then lifted as complete sections. Counterweights are fitted to ensure proper balance during operation. A series of load tests, safety system checks, and communications trials follow to verify stability and functionality. When all inspections are passed, the tower crane is fully commissioned and ready to participate in wind turbine dismantling work. To remove the turbine's internal engine, technicians isolate all electrical and hydraulic lines, then detach the generator housing. Using the tower's internal hoist, the engine is unbolted, lifted clear of its mounts, and carefully lowered down the shaft. Guide ropes prevent contact with the walls, ensuring a controlled descent for safe extraction at ground level. In the early hours of the Special Transport Truck Show 2023, a remarkable spectacle unfolds on the streets of towns and cities. Convoys of heavy-haul trucks depart from various company depots, carefully navigating the local roads on their way to the exhibition grounds. These trucks, each built for extraordinary tasks, stand out not only because of their size, but also due to their meticulous preparation and eye-catching designs. Their departure is a carefully coordinated operation, requiring experienced drivers, escorts, and precise timing to move safely through urban environments. As the trucks emerge from industrial areas and enter town streets, the sheer scale of the vehicles becomes immediately apparent. Multi-axle tractors, extended trailers, and low loaders occupy almost the entire width of the road. The drivers skillfully negotiate intersections, roundabouts, and narrow residential streets, demonstrating a high level of precision and control. Local traffic often slows or pauses entirely to accommodate these massive convoys, and the rhythmic hum of diesel engines fills the air as the trucks advance slowly but steadily toward the show. Residents lining the sidewalks witness a scene that is both extraordinary and almost cinematic, while enthusiasts stop to photograph or film the procession. Each truck is polished to perfection, with chrome accents glinting in the morning sun, custom paintwork reflecting company logos or intricate artwork, and carefully positioned lights adding a touch of theatricality. Even though these trucks are designed primarily for utility, the visual spectacle of them traveling through everyday streets makes the ordinary urban environment seem temporarily transformed into a showcase of engineering excellence. The convoys move in a coordinated fashion. Pilot cars lead the way, guiding the heavy-haul trucks and ensuring that the route remains clear. Some vehicles carry extremely long or wide loads, such as industrial machinery or construction modules, requiring temporary road closures or careful navigation around street furniture and traffic signs. Drivers communicate constantly with each other and with escort teams, adjusting speed and position to maintain safe distances and prevent any mishaps. The synchronization of multiple trucks moving in tandem highlights the logistical planning behind such operations. Throughout the journey, the contrast between the everyday townscape and the extraordinary vehicles is striking. Narrow streets, quaint residential facades, and public squares provide an almost cinematic backdrop to the procession of massive trucks. The soundscape is equally impressive. The deep growl of engines, the occasional hiss of air brakes, and the rhythmic clatter of tires on pavement create an immersive, industrial symphony. Every turn, every careful maneuver, and every pause to allow oncoming traffic to pass becomes part of a coordinated choreography that underscores the driver's skill and experience. Spectators often comment on the remarkable professionalism displayed during these departures. It is not merely a parade of large vehicles. It is a live demonstration of the challenges inherent in specialized transport. Drivers must anticipate tight corners, changes in road surface, and unpredictable urban obstacles while maintaining the safety of both their loads and the public. Each truck, from powerful 8x4 tractors to multi-axle low loaders, showcases engineering capabilities that allow these enormous vehicles to travel safely under conditions that would challenge even smaller transports. As the convoys continue their journey toward the exhibition grounds, they leave behind a trail of fascination. The sight of multiple heavy-haul trucks negotiating urban streets captures the imagination of all who witness it. This movement of extraordinary machinery through everyday environments is a unique hallmark of the Special Transport Truck Show, providing a glimpse into the world of specialized logistics long before the vehicles reach the exhibition site. By the time the trucks disappear into the distance, their passage has left a lasting impression. The residents, the enthusiasts, and even casual passers-by have shared in a rare experience, observing some of Europe's most impressive heavy-haul trucks navigating streets with a combination of force, finesse, and unwavering professionalism. The departure itself becomes a moving exhibition, showcasing the strength, skill, and spectacle of specialized transport. In this demonstration, we observe oversized load trucks executing a precise 90-degree turn. These massive vehicles, carrying extremely wide or long cargo, require careful planning and coordination to navigate tight corners. Spotters and escort vehicles guide the drivers, ensuring the safety of both the trucks and surrounding traffic. Each turn is approached slowly, with adjustments made to the steering and trailer alignment to prevent collisions or tipping. The drivers skillfully maneuver their loads, accounting for the extra length and width. This process highlights the complexity and precision required in transporting oversized cargo, where every movement must be calculated to ensure a safe, successful turn. During construction works along the Costanera in Córdoba, a crane from a local construction company overturned when the ground beneath it gave way. The incident required immediate and professional intervention to ensure safety and minimize further risks. Gruis Martin was called to the site with two heavy-duty cranes, one with a 200-ton capacity and another with 150 tons, to carry out the complex rescue operation. The team first secured the surrounding area, ensuring that no personnel were at risk and that traffic along the Costanera remained controlled. Once the site was stabilized, the 200-ton crane was positioned to lift the main body of the overturned crane, while the 150-ton crane assisted in balancing and guiding the structure. Through careful coordination, precise rigging, and constant communication between operators, the fallen crane was gradually lifted and repositioned onto stable ground. The operation required meticulous planning, as any sudden movement could cause further damage or endanger workers. After several hours, the crane was successfully uprighted and safely secured, demonstrating the expertise and efficiency of the Gruis Martin team in heavy equipment rescue operations. In this remarkable operation, Colette Heavy Transport undertakes the careful movement of a colossal 225-ton tank through the streets of Fazeley, Tamworth. The tank, an imposing and meticulously engineered piece of machinery, demands exceptional planning and precision to navigate the narrow urban roads. Prior to departure, detailed route assessments ensure all obstacles, from tight corners to overhead structures, are accounted for, guaranteeing a smooth passage. The operation unfolds with a convoy of specialized transport vehicles, each designed to support the immense weight and maintain stability throughout the journey. Skilled operators coordinate every maneuver, using communication and signaling to guide the transport safely along its path. Local authorities assist by managing traffic, temporarily adjusting road layouts, and ensuring public safety during the tank's transit. As the giant load slowly progresses through Faisley, onlookers are captivated by the scale and precision of the movement. Every step of the journey highlights the expertise of Colette Heavy Transport in handling some of the heaviest and most challenging loads in the world, demonstrating their commitment to safety, planning, and technical excellence.